and gentlemen, welcome back to the Jack World Live demonstration area. We are extremely pleased to welcome back Charles Tur from MVP this afternoon. MVP is a global manufacturer of fluid movements and product solutions for industrial applications in composites and adhesive markets. Charles Tur is a renowned expert in resin transfer molding and infusion technology. He will show us how to implement MVP's secure vacuum bag seal to reduce consumable costs and waste, decrease time and labor requirements, ensuring security. Charles, the demonstration floor is yours.
Thank you. Welcome, everyone. I'm going to show you on that mold how we apply the vacuum bag, how we secure the vacuum bag. And tomorrow, I will run another demonstration where we will infuse the part. So I will start on the presentation. Up. Perfect. So the point is, we find around the world that it's hard after the COVID to find workers. And it's hard to find workers who work well, safety, secure. So we have to develop a system where it doesn't matter what we do, it will be safe. And that's why we developed the SVB seal. So when infusing a part with a plastic bag, we use tacky tape to seal it. So what it means, we have to apply the tacky tape all around the mold, and we have to take care that we have no leak on all the folders. It takes time, and sometimes we miss it, we are not so good, and we leak. The use of the SVB seal secure no air leak and guarantee no air leak. So if you look at the pictures, you have a swimming pool on the left. How we infuse a swimming pool, I will say 15 years ago. And on the right, how we infuse a swimming pool today. As you can see, first we use an injection machine. Then we use a reusable resin channel. And there is no tacky tape to seal the bag. The only consumable we have is the plastic bag itself. So that's the solution we find, the SVB seal. It's a two-part seal. One, to push the plastic into the groove of the mold. That can be inflatable if we want. And the second one, which will be clipped on the first one, to secure the vacuum. So we have the mold, as you can see here, where we have a groove. Below that, we have a pipe all around connected to the hole. So we load the glass. We put what we call a resin stopper to be sure that the resin will not go to the pipe of the mold. We can put a vacuum channel if we need. Then we come with the plastic bag. And at this time, we put the first part of the SVB seal down into the groove, and we push the plastic inside the groove. We don't care about the folders. We just put the plastic inside. Then, after it, we are able to apply the vacuum. Of course, the vacuum that we apply is good, but it's not perfect because we have air leak. Where this air leak is coming from? The air leak is coming from the edge of the plastic bag. So, to guarantee that we have no air leak, we trim out the excess of plastic along the SVB seal. Then we come with the second part of the SVB seal. We clip it into the first one. And through the tube, we apply the vacuum. And when we apply the vacuum here, we guarantee zero air leak. Why? Because we pull the vacuum where the air can come from. So there is no possibility of leak. And then if we want, if we use a large mold and we are afraid that the seal will escape from the channel, we can inflate it. We can inflate it until 45 psi, which is a 3 bar, to compress a little bit more the plastic. So that's how it's working. We have the mold, we have the plastic bag. We push down the plastic bag into the groove. We apply the first vacuum. We trim out the excess of plastic. We put the second part of the seal. Then we apply the vacuum through the little holes, a communication we do between the tube and the surface of the mold. And then we just ready to inject the part. Here, I wanted to be sure there is no air leak. So I inject the part using injection mat. It takes 5 minutes to inject the part. But the gel time of the resin was 1 hour. 55 minutes for the air transport if you have any air leak. And as you can see, it was nothing. So we have some valve and a sensor to control the infusion that I will introduce. And that's the part after demolding. As you can see, there is no air bubble, and there is no gel coat on that part. Okay? So before I continue, let me show you how it's working. So I have a mold here where I load already the fiber. The fiber is carbon. I have 3 layers of carbon. And on the top of the carbon, I put the Enfuply. Enfuply is a combination of a perforated film and a net on the top of it. That's what Composite One has used on the previous demo. Then, now, I'm going to use a collapsible resin channel. The collapsible resin channel is working like that. I have my channel here. When I pull the vacuum inside, I collapse the channel. So the resin will arrive from here, will flow here and here. When the injection is finished, what I'm doing, I stop pulling vacuum and it comes back flat. You will not be able to tell how we inject the resin. There is no resin waste. But because of the size of the resin channel, you can travel with the resin for like 15 meters. So it's very interesting instead to use the spiral tube. And that part is in silicone, so it's self-release and it's completely reusable. So this is the first thing that I load on the top. Then nearby, I can put what we call a IFA connection to connect the sensor. I will make space for it here. Voilà. So now I have to come with the bag. So I have a multi-layer bag from Aerovac, 80 micron. I pre-cut it. And of course, is a little longer. Voilà. So I load it on the top of the mold, like that. And as I explained, I don't care about the folders. Folders is not my problem. What I do here, I have my first part of SVB seal. And what I will do, I will pass it through the plastic bag, the valve to inflate it. I will put it on the border. Voilà. And I will connect it below. Sorry. Voilà. Perfect. So now the only thing I have to do is to take the SVB seal and to put it into the groove, taking care that I have enough material to fill the part. So of course you can work with a pre-cutted film in production. Here is just a demonstration. Voilà. I will put some wrinkles where I have my connection. Perfect. Voilà. Up. I turn around. I take more material here. The good thing is that you don't care about the wrinkles. That's very nice. Folders, no folders, doesn't matter. Just take care that you have enough plastic where you need it. Voilà. Alors, what we can do also is like a roll to push it down. It's easier. Voilà. So when it's a little bit longer, it's because I stretch it too much. Voilà. Allez, hop. Fine. Voilà. So I have the seal inside. And now I'm able to pull the vacuum. Why? Because the plastic is compressed. So I start my vacuum pump and I start pulling the vacuum. We take a little time to apply the vacuum. I take care that the plastic is properly done. I take care that the plastic is on the right position. So the same as you pull the vacuum when using a techie tape. Voilà. So now what I can do, I can trim the plastic out because this is what I will need for the next step. So I have electrical scissors. And I just cut the plastic out. All along. I'm sorry, my blades are not new. So you can see that we start to have vacuum in the middle. Voilà. Almost finished. Voilà. So as I explained, we can pre-cut the plastic like that. We don't waste too much. Okay, so now what happened? We are under vacuum. But that vacuum is not perfect. Why? Because it's leaking here. Okay, if I want the perfect vacuum, I have to close it here. So this is what I'm going to do now. For that, I have to clip the second part of the seal in the first one. Problem is, this is silicone, and silicone is rubbering. So just to make easy, I put some water and soup on the top of it, and it will directly slide very easily inside. Fine. So now I have my second part of seal. And I just clip it inside all around. Voilà. So as you see, it's easy to clip it. Voilà. So the good point is that the seal will never be in contact with the resin. So it's completely reusable. Voilà. As you can see, sometimes we are a little bit longer. Allez. Voilà. So to help to push it, we have a roll. Just to clip it properly into that. Voilà. And to push it well, to clip it. Voilà. Perfect. So we just care about the corner. Voilà, that we are good. And now I applied the second part of vacuum. And now we are under vacuum. And at this time, we guarantee no air leak. We guarantee no air leak. Why? Because we pull the vacuum where we can have a leak. So in this case, we don't have air leak. And that's it you have to do. Now we want to control if we have an air leak or not. So how to control it? This is our connection. And we have a connection to put our insert. Up, we put that here. This is where I'm supposed to introduce the resin. Voilà. And then I have a blank plug. So I have one to introduce the resin, one to pull the vacuum on the resin channel, and one to connect what we call the PPVS. So I will connect the other. And then during this time, what I can do, I can use a blank plug that was here. Ah, it's here. Okay. And now I'm under vacuum. Okay, everything is under vacuum. So what can I do? Here we have voilà. Air leak controller. Voilà. Step by step. Okay, so here we have the valve that we use to introduce the resin. So we put it out, and we just connect here the valve. Then we have the clips to be sure that it don't escape. Nearby, we have a sensor. The sensor is using to control the valve. So what happens? When you inject the resin, by the machine, you can overpressure the bag. So the bag will move up and the resin will flow on the top of the glass instead to flow inside. Here, there is a sensor who will control it. He will give the air signal to the valve to open and to close according to the pressure of the resin flow. So if it sees that there is too much pressure, it will close the valve. The resin will flow, then at this time, it will stop. And then when the resin will flow, it will give the signal to open the valve again. Now we have nearby the last one, which is the valve to open the vacuum. Here, there is no leak because the vacuum we put on the resin channel has no connection with the vacuum we have on the part. So we have one connection here that I miss, which is here, where we put the vacuum coming from the pump. So we have the vacuum from the pump, we connect here, and we put it inside. Now, if I open the valve, nothing will happen. Why nothing will happen? Because the valve is closed. So the vacuum is open here. We have vacuum, but here we have no vacuum. When I send the air signal to the valve from the machine to start the injection, I send the air signal also to the valve. We open the valve, the vacuum passes through. When I stop the machine, I stop the vacuum on the valve. The collapsible channel comes back. The point is, if you stop the vacuum and you leave it closed, the collapsible channel stays collapsible. So you need the air coming in to be sure that it can come back. The valve stops the vacuum but let the air pass through. It's a special valve designed for that by MVP. So this is all the connection we have for the system. Voilà. So let me show you on the presentation how it's working. So that's the SVB seal, and that's the air controller. So I forgot to show you how the air controller is working. We have the possibility, as I explained, to inflate the bag. So we have a connection here. And if you look at here, I can inflate the bag until 3 bar. We have 3 bar on the connector. Okay, and when I do that, I compress more the plastic into the groove, so the seal cannot escape. That's the advantage of that. I will continue the presentation. So we have a kit that we deliver with the seal. That seal works not only for flat mold, it works for all kinds of form. We just have a radius to respect. The groove is standard. To build the groove, we have what we call a groove seal that you put on your pattern, and then you laminate your mold on the top of it. That groove is standard. It will work for the SVB seal, but it will work also for the silicone membrane. So our recommendation, when you make a new mold, is to have the groove on the mold. Like that, you will be able to do everything. You can do light RTM, you can do SVB seal, you can do silicone membrane, you can do everything. Then you will be able to put the SVB seal. So that's the dimension. You put it at 30 millimeters from the mold border. And then you have some radius to respect. So you go for minimum 120 millimeter radius. Less than that is complicated to pass with the SVB seal. So as you can see, it works also for different kind of mold, different form. Where's the timer? Oh, perfect. Okay, so below the mold, we have a vacuum channel. Then we load a tube, a poly tube on the back that we laminate on the top of it. And then we tight it with gel coat. Then we make every 20 centimeters a little hole in diagonal of 3 millimeters. Is a connection for the vacuum to be sure that we can pull the vacuum on the seal. To assemble the seal is very simple. We use a silicone glue, a one-component silicone glue. So we cut it. My recommendation is to cut it a little bit shorter. You see here, I cut it on the right dimension, and sometimes it's a little bit too long. So it's better to cut it like 5 centimeters shorter, then you stretch it a little bit and you don't have any wave at the end. And to bond it and to guarantee there is no leak when you inflate the air, we put a tube inside and we glue it edge to edge on the silicone. Then we leave it cure, and we do the same with the lip seal. And the lip seal is only bonded on the edge, and it works perfectly. Here we have a connection, don't know where is it. Yeah, here. And there is no problem, it's just bonding edge to edge. And then we have a valve, a special valve that we pass through to inflate the dynamic seal, the SVB seal, sorry. So for that, we make a hole, and we glue the connector through that, and we screw it. And then it's ready to pass through the mold through the connection. And we can inflate it until 45 psi. So that's the system and the solution we propose today. Tomorrow, I'm going to infuse the bag, to infuse the part with the seal. Like that, you will be able to see how it's really working with the resin inside. Thank you very much for your attention. And
thank you so much, Charles. We have time for 1 or 2 questions. Is there anyone that has any questions for Charles? Okay. As he mentioned, he will be back again to continue the presentation
tomorrow afternoon.
Tomorrow, 10:45 in the morning. And if not, you can always visit Charles and the MVP team at stand 5U58 if you would like to discuss further their expertise. Ladies and gentlemen, our last live demonstration of the day will take place in 15 minutes. If you are available, please come back to see Rock Tool right here in 15 minutes, who are going to explain how to unlock the potential of heat and cool technology in compressing molding. And if not, enjoy your afternoon at Jack World. Thank you very much.